Yeah. Good evening, everyone. So,
Good evening, sir.
in the last session, I hope week 11 concepts has been covered. So, in this session, we'll discuss about uh, week 11 practice system and questions. And if you guys have any doubt in week 11, it also we can cover it in this session. And I think this Wednesday is the deadline for GA, right?
Yes, sir.
Yeah, sir.
So, yeah, let me share my screen. Is my screen visible?
Yeah, sir.
So, in week 11, we majorly saw about two things, right? In week 10, we saw about how to represent graph uh, in matrices form, which is a dictionary of dictionary, right? So in week 10, that is the thing we majorly saw. Here we are studying about the one of the graph, which is DFS. DFS means depth first search. And also, I hope the adjacency matrix has also been covered in last session. Is it? Adjacency matrix. Anyone?
Sir, you were not audible to us.
Yes, sir. Your voices have been lagged, so we are not able to hear you.
Kindly repeat what you have.
Is my voice breaking?
No, sir, now it's clear.
Yeah, now it's fine, sir. Sir, can we repeat it once?
So, as adjacency matrix concept has been covered in previous session. Okay.
Yeah, sir. It was covered. Yeah, it was covered for the safety.
And other concept which we will be looking at is recursion. So, because the DFS algorithm mainly uses this recursion concept. If someone raise their hand, any doubts before moving to activity practice assignment questions?
No, sir. No, sir.
Okay, this is what we'll be looking in week 11. Oh, okay, we'll go through the first question then. Okay, here the question comes from recursion concept. See, the first question says the unique is a procedure. Here you can see the procedure has been declared and it accepts L, which is nothing but a list as input. And finally, what it returns is it should return the unique elements in the list after removing the duplicates. So for that, they have already given the some part of the code and we need to pre-fill the code so that it returns the unique element. Returns the unique element in the list. So what does mean by unique element in the list? Let's say
Sir, you are not audible.
my list
Sir, your voice is
One,
No, sir. It's not available.
one, four, five, four, three.
Sir, you are not audible. Your voice is breaking.
Okay, just a minute. I'll check with
But
my.
now it's fine.
Just a minute. I'll check with. Is it better now?
Yes, sir.
Yes, sir. Now it is fine.
So it's yeah, someone raised your hand. Admin may know your name. Week 2, week 12 will be released. Okay. Let's assume this as my list. 1, 2, 1,
Sir,
4, 5, 4, 3.
sir, week 12 has been released. It
No,
is
no, it
ready.
has not released so far. It will be released by tomorrow, I guess.
Okay. Thank you.
Okay. So let's assume this as a list. So what will be the unique of this list? If I take unique of this list, it will be 1, 2, 3, 4, 5, right? By removing the duplicates. So it's gonna remove the all the duplicate values, right? So don't worry about the order. I just return the unique elements by taking from the L. So this is what our procedure should do. Okay. Let's say the list itself already unique. 1, 2, 3, 4, 5. The unique of L should the unique of L should be equal to your original list, which is same as 1, 2, 3, 4, 5, right? So instead of iterating one by one, what we are gonna do is we are gonna call with recursive function. Recursive function means what? Can someone? I hope yesterday it was discussed.
It repeats till the uh, function is not completed.
So every recursive function will have the base case, if I say. It will have one base case and it will call the function by itself, I could say. Call its own function. If I want to do it, is call its own function. Right? It will be keep on calling its own function until the base case is true. Right? This is what the recursive function means. So here, let's see the already given code. The init element, they initialize to empty list, and they are saying if length of L less than or equal to 1, then you return L. So this is your base case. If we carefully look at, this is where we are returning something. So base case will return your value, and after that they have initialized a new variable init elements equal to init of L. So what this will do, it will take the init of list by removing the last element. For example, here it will ignore the 3 and it will take up to this, right? So this will be taken and stored in init elements. then we need to write our logic so that it gives the unique number, it returns the unique elements from the list. So for this question, let's take this as an example. So where, let me erase this again. So we'll take the list 1 2 1 4 5 4 3. Okay. So let's execute this code with this. Let me, is font size are visible?
Yeah.
Yes, sir.
Okay. Let's consider this. So first what it does, by executing the procedure, it will have init of L which stored in init of element. So it will take 1, 2, 1, 4, 5, 4. And 3 is your nothing but last element. So 3 is your nothing but last of L, right? So what this will do, you check for all the options. First option checks, here you can see, the first option checks if it is a member, then you return. Member nothing but it returns true or false. If this last of L present in init elements, init of this is nothing but init elements, right? So if this 3 is a member of this init list, then it returns true. Then what it returns is it calls its own function by calling unique. So it's nothing but it's calling its own procedure or function, right? So, but in else case, if you see, this else case returns again unique of init of elements plus last of L. So it's nothing but it's adding the last element in the list. So if this is not a member in this init of L, it's adding that element in the list, right? So is this confusing or is it clear? The first option. Just I want to know the approach of code, not the answer.
May I see the question once?
Yeah, just hmm.
So return L means in the fourth line.
Nothing.
Return L, the fourth line.
Yeah, in fourth
So
line it will return that empty list. So sorry, the whatever the last if finally your list is only contains only one element or no elements, so this will return your original list with your empty element. So this is your base case. I see.
So, but I'm not getting that. If we fill the code, the first code in the pseudocode, then what will be the conclusion?
I'll come to the point. So at least what it does, I wanted to know. Like I will explain with this example so that it will be clear how exactly this recursion.
Sir, return L means it go back to its original list means sir 1 2 1 4 5 4 3 this one.
Not that one. I'll explain. Maybe. So I'll briefly explain all the option why the option is correct. But
Sir,
I'll
the
explain with
last
the. I'll take this example and explain with the correct option with the step by step. Then it will be clear.
the last L is nothing but the 3, right?
Yeah.
Which I have you taken that example.
Hmm.
Okay.
So the first option is wrong. I'll tell you why this is wrong. So we should return a list, okay? But what does this does? Plus plus. Usually, how we used to append the list, we used to append the list something like this, right? With this empty list or something. So here it doesn't have a list, so this first option is wrong. The second option doesn't even returning the unique elements,
Yes.
right? If let's say this is my list 1 to 1 or 1 to 3, if my last of L is also 1, so since this is a member, it will return true and it will return 1 2 3 as an element. So
The
which
fourth
is
one
not
would be right.
which is not unique. In this case, if it is again 1 is there, it will return 1. So this is not the correct solution. So it should call unique of init of L. So this is also
Oh,
wrong. So again, this is also wrong. This is since it is returns just init of elements. And fourth one is the correct option. Okay, I'll explain this solution with respect to the fourth one so that you will understand how exactly the code works, the recursion one. Okay. So just let me erase the unwanted things. So initially what our code does checks if length of L less than 1, it returns the L. This is the initial procedure. Then what it does, init of elements equal to init of L. Then we are filling this pseudocode, this fourth. Okay. This is what we are doing. So now for the first one, I'll keep a track. How does it work? Let me erase this also so that I can neatly keep track somewhere.
Sir, cannot.
Why this calendar is invisible? So let me just note it down. If length of L is less than or equal to 1, then you return L. Then what you are taking, init of elements equal to init of L. And then you execute the pseudocode procedure. So for example, I'll take this list L equal to 1, 2, 1, 3, 4, 5, 4, something. Okay. So initially, my init of L or the init element will be what? 1 to 1, 3, 4, 5, right? And my last of L
Three.
will be 4, 4 here, 4, right?
Yes.
So here in this case, this will return true, right?
Yes.
So if it's returning true, because 4 is present in my init of L. So what it will do, it will call the function again.
Unique init. Yeah.
So now it will call the function unique of the list is now 1,
Uh,
2, 1, 3, 4, 5. This will be my list now, right? Because I don't want the last element. Because since it's duplicate, I haven't added in my original list. That's
so
something called,
1 is also a duplicate here.
uh, I'm taking just as of now, this is what it's written. We'll come to the point how it will remove the. Okay. So I'll keep track everything in the unique list. So this list will be finally written, right? So or this list will be keep track of maintaining what it should return. The empty list. I think empty list is there. No, empty list is also not there. So it will automatically keep track by default. Okay. So up to this is clear, right? Hello.
Yes, sir.
Yeah.
So next again what it
Yeah.
will do, it will go and check whether length is less than or equal to 1. Because my current list is 1 to 1, 3, 4, 5. Now my current list is nothing but 1 to 1, 3, 4, 5. This is my current list. Now my length of the list is not less than 1. So again, it will calculate the init element. So this init element will give you 1 to 1, 3, 4. And last of L is what? 5, right? Now this will return false, right? Because 5 is not part of this init element list.
So, but as you have taken that L is 1, 2, 1, 3, 4, 5, which does not has 4, but there is no like kind of assignment to L that it will be the removed, it will remove 4.
It will remove 4, I'm not getting.
Like the initially the L list is 1, 2, 1, 3, 4, 5, 4.
5, 4.
And now you are
Yeah.
saying that L will be 1, 2, 1, 3, 4, 5. But here there is nothing kind of in the pseudocode that it will remove the 4 from the L.
It's not removing actually. It's keeping track of what I should return. If you see in the else block, it's adding the last of L in your result, in your return state, if you carefully see. If here, in this case now, 1 to 1, 3, 4, and 5 is your last of L. Since this is false, now it will execute this return statement. So this return statement, what it will do is return unique of this 1 to 1, this 1 to 1, 3, 4. Then what it will do, whatever this list is there, you don't know what's the result is going to be, this result, right? But it will add the list 5 to it. Sorry, the element 5 which is in the list. This is what this is doing. Now, whenever you find some element which is not part of your init element, that what you will do, you will add it here.
Sir, I have a doubt.
Yes.
So here we are calling function unique init elements. So that should give us unique elements like 1, 2, 3, 4, 5, not the duplicate, right?
Yes.
Why
Final
why
value
we get,
should be unique.
but
This is the
sir,
second step. This is the second step which we are in.
so sir, the final value would be in the like last. We'll get that the last L would be our final list.
Yeah. Last of L will be keep on adding. In next case, let's say this is my second step. This is my first step which return something this 5 will be keep on accumulating. This is nothing but this is the list which will be finally written. This will be keep on accumulating. If you see in the third one, now what it will do, it will now your init element will be 12134, sorry, 1213, and your last of L will be 4. Now in this case again what it will do, it will return unique of 1213
Yes.
Okay.
Okay.
plus
5 and 4.
4, 4, right? This is what actually the code is written, right? Is it clear?
So sir, we are accumulating the last
Yeah.
value,
I'll
which
come to
must
the point how it will accumulate. Okay,
no.
that will
I'm
accumulate.
asking some. I'm asking
That will
for something
accumulate.
else. Yeah. Okay. So
You are
we'll
saying the list should be like this, right?
no sir. 5 and 4. Yeah. Yeah. That it should be like
Or
that.
5 comma 4, right?
Yeah.
I'll come to the point how it will accumulate. Okay, but this is what our pseudocode is doing, right? Just adding the last of it. Is it clear?
Sir, the first line,
Hmm.
if member, uh, so it is checking the last element
Hmm.
of
Whether this
the
last element is in my list or not.
yes,
So
sir.
this 4 is not present in my init of L, so it will
Yes,
return true or false based on.
yes.
Okay.
Okay.
Okay. In next fourth step, since this returns 1213, now my init of L, that means the init element will be 121, and my last of L will be 3, just 3. So this again, this will be false
Mm,
since 3 is not this init of list. So what it will do, return unique of the list 121 plus plus. Again, this block will be executed since this is false. Again, what it returned, again it called the function again. So in fifth step, what it will do, again it will go the init of L, which will be 1, 2, and last of L, which is just 1. Right? Now in this case, it will return 2, since 1 is also present in init of L, right?
yes.
So here now in this case, what it will return? It will return the unique of just 1, 2, right? It won't add the last element because we found that last element is a duplicate value which is present in my init of list. Okay. Then in sixth step, what it will do? Again, the 1, 2 will come. So my init of L will be 1. My last of L will be 2. So this will return false since this 2 is not in my init of list. So what it will do? It will return unique of 1 in the list plus
2.
Okay. Now finally I have a list just with 1. Now if you go and check, this will become true, right? Because my length of the list is less than or equal to 1. So this will return, finally what it will return is the element with 1. Okay. This is what my pseudo code returned. Okay. Now is the beauty of the code, how it will accumulate and give you the result. That's the whole concept of recursion. Okay. I'll take another color. So my final step, actually the 7th step, which returned 1. So it returned 1 for this particular one, right? This one. Is it clear or is it confused? Because for this only my 7th step returned just 1. So this is my base case. Since this is the base case, I said. So base case means it won't call the function again. It got terminated. So my 6th step will be now what 1 plus 2, right? So my 6th step will become 1 comma 2. Again my 5th step, which is
I have a doubt.
the answer for this. Yeah.
Sir, how we adding this? Because there is no nothing signed for this accumulation. Like how we are accumulating each value when there is nothing signed for that.
When nothing assigned for it.
Yeah, signed for it.
See, this is how my function has been written, right? So I call this one and I got something this. And again I called this one and I got this. Again, after calling every unique, finally I got 1. So I'm just substituting in a reverse way. So for this unique of 1, what I got is just a element with 1. So I just substitute here in the 6th step 1, which is already there with 2. So this will become my 1 comma 2, right?
So, sir,
Because
we gonna to backtrack.
yeah.
Okay.
So basically we are backtracking here. So by calling this function, we got this value. So by calling this function, we got this whole 6th step as a value. So now here also what it will be? It will be 1 comma 2 1, right? Again by calling this, what we got? Just 1 comma 2, and we are adding 3. So it will be 1 2 3, right? Again by calling this, what we got? 1 2 3, which is in my 4th step. 1 2 3. Then you add 4.
Four.
So this value will be 1 2 3. In second step, the unique element will return again 1 2 3 4, and the last element you are adding it, which is 5. So this is your original function which you called the first time you called. So this will finally return 1 2 3 4 5 from the second step. So your final answer will be 1 2 3 4 5. That's it. So basically what recursion does is, so basically what
Sir, in
recursion does is it
recursion,
calls the
why we not set a step for backtracking step?
step 4 backward. We checked, right? I haven't missed. For step 4, we got 1 and 2 from the 5th step, right? For backtracking from this.
Sir, but the
Any doubts before moving to next question?
Sir, option A, why wrong? Option A.
In option A, we haven't added using the list. It just add last of L, if you carefully see. It has plus plus last of L instead of the square bracket.
Okay.
Any doubts here? How the recursion works? Basically, it calls one function, it calls function within again and again. Finally, it gets some base value, which is nothing but this is the base value when the function gets terminated instead of calling again. So from this base value, we are just backtracking it, what are the values it's got. Then finally, we are returning the final result.
Sir, so we are adding whenever it is coming false, right? Whenever it is coming true, that value we are not adding. Is that right?
Yeah, here we are not adding, but again, we are still backtracking it if you see. In the fifth step, I haven't added anything, but still I backtracked and got the result from the sixth step, which is nothing same.
Sir, for backtracking, we do not write any code in it.
Yeah. Sorry. We do not?
For
Sir,
backtracking, we do not write any code in it.
No. Internally, this is how the program works. I don't know, this data structure has not been introduced, but I'll tell you how it works just for a brief. We call stack data structure something. So for recursion, it uses that data structure to internally maintain this, and it will finally returns the result to you.
Okay, sir.
So which you will study in PDS with the stack data structure. So it's nothing but a stack data structure will be something like this. It's like you keep on placing the books one above the other. If you want to take some book, you need to take the top one, then only you can take the below one. So for example, if I put the numbers, let's say this is book 1 and book 2, book 3, book 4, book 5. Okay, this is how it got placed in a container or something like this. If you visualize, if you wanted to take book 1, you need to take all the books from this stack out of it to take the book 1 and read, right? So if you carefully see, this recursion also similar kind of that. So in order to get this value, in order to read this, you need to take pull out of all it, and then you have to take this book out. So
Sir,
this
but
is how the recursion also maintains. I don't want to go through the details of this data structure uh, since you will be studying in PDSA course. But
so,
this is how the recursion maintains internally using this.
sir, but like we have to do this backtrack and all. So how will we get to know from the code in the exam?
Uh, but again, you need to visualize something like this only. You don't have any other option.
Because in the
Because
exam we have like many codes. So how will we identify that in that we have to put this method and we have to do backtracking?
for that, again, I said, right, there will be one base case in recursion, as I said. There will be a base case and there will be a recursive calls, which is nothing but it will call its own function. So this base case will end the function, right? So for example, the length of L is less than 1, this is your base case here. Again, remaining all what it does is it calls its own function, which is nothing but recursive call. So from this you can identify this is a recursive function. I need to apply this backtracking method. Is it clear?
Sir, can you explain once again this backtracking is somewhat confusing. Like last 7th step, I am clear, like we got 1. After that, how did we backtrack That can you explain in brief once more?
Okay. So in last 7th step, we got the final value, which is 1, right?
Yes, sir. Yes, sir.
In 6th step, so this value came by calling which function?
Unique
Unique of
initial element.
1, right? By calling this one, I got this value. Okay. Now you know by calling this only, I got this one. What you do, I'm just substituting here. So this return of unique of 1 will be 1 now with the list, plus you are adding 1, 2.
Okay.
Okay. Now the 6th step value, you know, this is nothing but 1, 2, right?
Yes, sir.
Please mute yourself if you guys are not speaking. I'm hearing some background noise. Okay. In 6th step, since you got to know 1, 2, I got the value. Now your 5th step, what it does is it calls the unique of 1, 2, which is nothing but the value of the 6th step, right? Because by calling unique of 1, 2, this function has been called again. Since you know the value, just substitute it, which is nothing but 1, 2 in a list. Now you go to 4th step, and it has a function unique of 1 to 1. So this 1 to 1 has a value of return unique of 1, 2, right? So every time it has the value of the previous step, if you carefully notice. This will have 1, 2, and you are adding 3 to it. And if you go to 3rd step, it will have the value of the 4th step, which is 1, 2, 3 plus 4. This is how it has been backtracked.
Okay,
I
sir.
know half of them might have confusions here, but try to understand. Maybe once you study the DSA course, it will be much clearer how internally it maintains the data structure and recursive.
Sir, if you explain the line 4 to all of like everyone should like understand this concept. The line
Hindi?
4 of yeah, in the line 4 of this pseudocode.
Mhm.
So that is the base case, right?
In line, no, 7th one is the line 4
No, no,
means
no, no,
this one you
not
are saying, the
here, sir.
return of it.
Yeah, in the question itself.
Yeah,
The
there is
given line.
this return of L is your base case.
Yeah.
Whenever the length of L is less than 1, it's returning. So how I'm saying this as a base case means this is the only return statement which I am seeing without any function call. I mean the recursive call. If you see all other return statements, you can see that is calling a recursive one, right? You see unique of init elements, unique of init elements. But
Sir,
this is
if
the
there
only
is no
return element
backtrack,
which doesn't have any function call. So this is your base case. That's why I'm saying this as a base case, remaining as a recursive. Any doubts here before moving to next question? This
sir,
is
if
very
there is
important.
no
Definitely you will be
backtracking
having,
step,
if there is,
no backtracking step, how we assume to backtrack in these question, yeah, in any question.
you definitely need to do backtracking for recursive question. Without backtracking, you cannot do the recursive one.
Every time we are kind of getting the new L. Is that right? So when we do backtrack, so every time we get the new L, right? Which is adding the
Yeah,
elements.
yeah. Okay. Can we move to next question?
Yes,
Yes,
sir.
sir.
Is this one?
Yeah, sure, sir.
Next question. Again, this is also a recursive call. A word is said to be palindrome if the word obtained by reversing it's same as the original word. For example, madam is a palindrome. Everyone knows what is mean by palindrome, right? For example, if I reverse this word, for example, if I take M as first, second A, and third D, and fourth A, and again M, it returns the same word even if I write it in a reverse order. If it is same, then it is palindrome. If it is not, then it is not a palindrome. For example, if you take any other word, let's say sir, if I write it in a reverse way, which is nothing but RIS, so this is not equal to this, so this is not palindrome. But if you in this case for madam, if you reverse it and write it, then it is same, then it is palindrome, right? So let's take madam as an example for palindrome, and I'll try to explain that in pseudocode. Okay. So it is. So the initial pseudocode which is given here, what they have done is the word list is the here word list which is nothing but empty list, flag equal to false, which is maintaining whether your word is a palindrome or not, and word list equal to explode x dot word. So what it does is whenever explode word is not there. Okay, so this is a function called explode. What it will do is, so for example, if you pass the string m madam, so it will split it and store it in the list, each letter in a list, m a d m. Now each letter is an element in your list. This is what this explode function does and stores in word list. So after that, what you will do, you will be calling this palindrome function and storing whether it is returning true or false, and you are passing this word list, which will be something like this. Is it clear so far?
Yes, sir.
Okay. Now let's try to see the pseudocode here. Here we need to complete the entire recursive function. Okay. So the procedure is palindrome is your recursive function. Okay. And as you see, this is the base case. This base case, I said, this could be one or more base cases.
Oriented.
Base case is nothing but which doesn't call its own function again, right? So here, if you see, this just simply returns true, which is one base case, and
So
here
this
simply
base
returns
case could
false.
be found in
This is
any other.
also base case.
No, I'm asking, sir, if like the base case is only in that recursion, or it can be used in any other function.
Any other function also you can use it. Generally, why we call it as a base case in the recursive function means it will have only the return value once or twice. Other than that, it will call its own function again and again. That's why we name it as a base case here.
Excuse
Got
me,
it,
sir.
sir. Sir, if I have to identify whether it is a case of recursion or not, we look for the base case, right? So I'm just asking
No,
if any other.
not just
Okay.
using base case. You have to see whether the function is calling its own function again or not. If you see here, return is palindrome. It's nothing but it's calling its own function, which is nothing but is palindrome. So by using this, you can say this is a recursive function. So instead of considering this base case, you can consider this whether it's calling its own function again or not. By considering this, you can say simply it is recursive function or not. instead of considering base case. Base case is the
Okay, sir.
idea I given where it's finally returning some value. From that we are backtracking. So that
Okay, thank you, sir.
in some of the recursive function we won't even backtrack. In this case we just need to return true or false. We won't be doing any backtracking here to return the final element, since it's just returning true or false.
Yes, sir. Okay.
Okay.
So I think the first one would be right answer.
Yeah. So here what it does is, if the length of the list is less than 1, then it's written true. For example, if you take any word with just only one letter, for example, A is a vowel, right? And if you take this, just pass this as a list, then it will return true, because even if you reverse it, the same letter will be there or word will be there. So this is true, fine. And if you take this word, madam, if first of L is not equal to last of L, here first of L is M and last of L is also M. So when you reverse it, that should be equal. If you carefully notice, madam, if I reverse it and write it, this as here, this as here, this as here, and this as here, this as here. So the first letter and last letter should be equal. So I can note as a position, for example, here. So this is 1, 2, 3, 4, 5. I just returned 5, 4, 3, 2, 1. So this first of L and last of L should be equal for all the palindromes. If it is not equal, I can directly say return false instead of checking my function again, right?
Yes,
Is
sir.
it clear?
Yes, sir. Sir, but
So in
why we, sir, for statement 2, why we have taken less than 1? Sir,
less
equal
than
to 1, it is, sir, if length of list
hmm,
L is less than equal to 1, why we have
hmm.
taken less than 1?
You could take equal to 1 also if you are assuming you won't pass any empty list. Yeah, this will also equal to. But here we considering the empty list could also be possible sometimes. If the word is a even
Sir,
word,
yeah, so sir, if there is one word left, like if we give it value like uh, one is equals to length, then it will remain one word in that list. So how we form that value, like
uh,
how we consider that?
that's the problem. If
Yeah.
I take a palindrome word with 4 letters, for example, say this is the Tamil word, I don't know, uh, which we call
Syntax is
amma. Amma means nothing but
SWS.
mother. Okay. If you return this, at last it will return the empty list. So in this case, again, you need to return true. That's why it's less than or equal to 1.
Yes, sir.
Okay. So if you found out immediately, then you return false. Else you need to check for other words. Then you take init of rest of L. So rest of L nothing but A, D, A, M, and init. From this, if you take a init, it is ADA. That is what you are passing to your function ADA. Now again you call the function. The length of L is not less than 1, and you take first of L, last of L, whether it is equal or not. If it is equal, fine, you just call the function again. Now the init of L, rest of L will be simply D, right? The rest of L will be DA and the init will be D for this.
Yes, sir.
So now this D, if you call D just unique of, sorry, is palindrome of D. Now the element has only one in the list, so it will finally return. So this option is true. Okay. In second option, I need to erase some of this. In second option, as you said, the problem with this one is if first of L is equal to last of L, it's returning fine, right? It just takes an opposite way. If first of L is equal to last of L, it's returning the call again. So in this case, it will return ADA if both are same, else it will directly return false. But the problem is here, as you said, it won't work for the even number of letters. For example, for this, it won't work. So that's why it is wrong. And in third option, again, if it is less than or equal to 1, it's returning true. And first of L equal to last of L, if it is equal, then you are taking again rest of L, init of L, that is fine, else you are returning false. So this third option or both option?
Yeah, so third option would be correct, right?
Yeah, seems correct. What's is wrong here? So it returns length of L
Yes.
will be less than 1, true. Okay, first of L, last of L, it returns init of rest of
So
L,
sir, yeah, it does not
everything
return
false.
is palindrome.
Yeah, this is true. Third option is also true. This fourth option is wrong because it returns true as soon as it shows that first two elements are true. For example, if you take this word madam, it just returns true by seeing just these two letters, right? It's not checking the entire word whether it's correctly coming or not. That is why this fourth option is false. Is it clear?
The options are not clear.
Yes, sir.
You repeat.
Where I want to repeat?
Sir, the option number third and fourth.
Okay. In option number third, so it's just the opposite of first option, right? So instead of in first option what we had, it is not equal to and it returned false, right?
Yes,
And here we returned this, we just swapped it. Okay, if it is equal to, then it's calling the recursive function again, which is same as the or first option. In first option we just called it an else, we just check the condition in opposite manner. In fourth option, this is wrong because it's returning true as soon as it sees just two elements. If there is a different word here, something called s, still it will return true by just seeing the first uh, two elements in the list. I mean the first element and last element. It won't even check the uh, elements which is in between. That is why it is false. Because if you reverse this word, it won't be a palindrome. Is it clear?
Yeah,
Yes,
sir.
sir.
yes, sir.
Let's move to the next function. Again, this is recursive one. Again, this is also. So here they were asking what is the value of calculate 12 comma 3. So first let's see how this function behaves. So here calculate a comma b is your function, and here can someone tell what is the base case here? The seventh
Return
line
equal
is
to
your
B.
base case.
Yes, sir. Seventh line.
If
Correct.
Base
A is
case.
equals to B, yeah.
Because in remaining return values, if you see, it calls its own function. So all these are recursive calls. So this is your base call, base value. Okay. So I'll take this as an example, whatever it's 12,3 as a question. So if you are passing, in short, I'll put just cal 12,3. What it will do, it will go and check whether A is less than or B. No, right? So it don't go to this block. Whether A is equal to B, no. Now it will calculate the difference and it will store 9, right? Now it's checking whether 9 is greater than 3. So yeah, it is true. Now it will go to the 11th line. Now it will call the recursive one. What it will do, it will calculate again 9 comma 3, right? So this is your first call, this is your second call. So it's not adding up anything, it's just calling within the call itself, like the palindrome one. So finally it will return the B value, whatever it's getting. Okay. So in next call, again you check whether A is less than B. No, 9 is not less than 3. This is also not true. 9 is not equal to 3. And you calculate the difference, which is 6. Now you check this if condition whether 6 is greater than 3. Yeah, it is greater than 3. Now the third call will be calculate of 6 comma 3. Now again this will become false. Just replace it with 6. This all will become false. Now again this will be true because now the diff will be 3. So okay, even this won't be true, right? Because 3 is not greater than 3. So it will call this one. Now again the fourth call will be calculate of 3 comma. So now again this is not true. 3 is not less than 3. But here the sixth line will be true. 3 is equal to 3. Now it will finally return a value called B. So it will return the value B, which is nothing but 3 here, right? So if even if you backtrack here, so this call this, this call this, this call this. So you got a value of 3 here. Again, this will be 3, this will be 3, this will be 3, right? Since you are not adding anything. So finally, for this value, it will return 3 as an answer, right? Any doubts? Hello.
Sir, we have assigned two values to A and B. We are
Mhm.
supposing two values of A and B, 12 and 3.
Yeah.
Then if difference is 0, the
If
second
difference
line,
is 0.
and if A is less than B, then return.
No, I'm not getting what you are asking.
So please repeat it once again.
If
Yes. So please repeat it once again.
no, I'm not getting what you are trying to ask. Can you repeat it?
Sir, whole procedure. Sir,
The fourth one, the fourth step here, whatever I mentioned. The
First,
fourth
he's
call.
saying that can you repeat the whole procedure one again so that, like, the whole question.
yes, sir.
Okay. So first it calls this function, right? Calculate 12 comma 3. So once it calls, it calculates the difference value 9 and it checks here this condition 9 comma, sorry, 9 is greater than 3. So it calculate diff comma b, which is nothing but 9 comma 3.
The
This is my
third
second
step. The third step.
second call. Again
Sir,
here
from
6 comma 3, right?
sir, from beginning we are asking from beginning. If difference is 0, sir, from starting. From first step, sir. The first line.
Initially my diff value is 0 and I'm calling 12 comma 3, let's assume. Now it's checking whether 12 is less than 3. No. Again 12 is not equal to 3. This is also false. Now this diff value, what it will store? 9, right? 12 minus 3.
Yes, sir.
Now whether 9 is greater than b, b value is what? 3, right? Then this is true. What it will do, it will call the second, it will call its function 1 again, which is recursive call. So it will be 9 comma 3, which I noted down as here 9 comma 3, right? Is it clear?
Yes, sir. Yes,
So
sir.
next
Clear.
call, it will be 9 comma 3. So here again you check 9 is less than or 3, whether 9 is not equal to 3. Then you calculate the difference 9 minus 3, which is 6. Again you check whether 6 is greater than 3. Yes, it is greater than 3. Now in this call, it will be 6 comma 3, which is my third call.
Yes, sir.
Okay. Now again 6 comma 3 is your call again. Now again you check whether 6 is less than 3. No. Again 6 is not equal to 3. Now you store the difference, and which should be 6 minus 3, 3, right? Now again you check whether 3 is greater than 3. No. So this won't be called. Instead of this, it will call this. So since both are equal, you will be, this is b value, this is diff value. So which is my fourth call. So this fourth call, what it returns, it is 3 comma 3. So if 3 comma 3 comes here, this function, this will be true, right? A equal to b. So it will finally return the value of b, which is 3. So again, if you backtrack, again the final answer will be 3. Is it clear?
Yes, sir.
Okay. Let's go to the next question then. Okay, next question is nothing but again same with calculate of 14 comma 17, I guess. Yeah, it's 14 comma 17. I guess let me check this. Yeah, it is 14 comma 17. What is the return value of 14 comma 17? So I'll erase this. So for 14 comma 17, I'll just quickly go through. Now if I call the function 14 comma 17, so now you check whether the a is greater than b, sorry, a is less than b. Yes, here itself this is true, right? So what it will do, it will go in a reverse way.
17,
So
14.
17, 14. Now all this condition will be satisfying again. Now again, if you check now, this will not be true now. 17 is greater than 14. This is also not true. Now you calculate the difference, which is 3. Again, the difference is greater than 14? No, right? Now here, this will call calculate of b, which is 14, and the difference is 3, right? Again, it will come whether 14 is less than 3. No, again it will call in a reverse way, calculate of 3, 4. Okay. Now again, this will be
Sir,
true
why we do it reverse?
because here it's this function, this line of code got executed, right? If
Sir, B is not greater than E because we have written 14, 3, so B is not greater than
oh sorry, my bad. Yeah, yeah, correct. So now again, since this 14 is not less than 3, 14 is not less than 3, so it will again calculate the difference, which is 11. Again, 11 is greater than
E. B.
3, right? Which is b, 3 here.
Yeah, 3.
So now what it will do, it will calculate the difference, which is 11, again 3. Now again, this will come true again here, 11 minus 3, which is
Sir, will it be 11 3 or 3 11?
11 3, right?
Uh,
Here first one is difference, again next value is b, because the difference which we got is 11.
Sir, how 11? A was 14.
14 minus 3.
Yeah.
Okay. Then again, if you calculate 11, it will be 11 minus 3, which is 8. Again, 8 is greater than 3. It will go and call the another function 8, 3. Again, it will come to this point 8 minus 3, which is 5. Again, 5 greater than 3. It will come calculate 5, 3. Again, nothing will be true. Again, 5 minus 3, which is 2. Again, 2 is not greater than 3 here. If you come to 10th line, 2 is not greater than 3. So it will calculate this. Calculate b is 3 and it is 8. Again, you come and see 3 is not less than 2. So this won't be executed. 3 is not equal to 2. Again, you calculate the difference. 3 minus 2, which is 1. So here again, the difference is 1. So 1 is not greater than 2 again. So b is 2. Again, it will calculate this one. Calculate 2, 1. Right? Again, 2 is not less than 1. It is not equal to. Again, you calculate the difference. 2 minus 1, which is 1. Again, 1 is not greater than 2. Again, it will come here. Calculate 1, 1, which is my difference value. So finally, after calling this a will be equal to b. So this will return answer 1. So even if you keep backtracking, so finally this will be 1, right? So the answer for this 14, 17 will be 1. Any doubts here?
No, sir.
So how
Sir,
many times it has been called?
Nine, sir.
9 times, right? So even I can count it 1, 2, 3, 4, 5, 6, 7, 8, 9. So the question is asking how many times the recursive call has been occurred, including the original call. So this is your original call. Okay. So 9 times total we call this function. Okay. And let's go to the next question.
Sir, why answer is 1 only?
Oh, sorry. I was looking at the old PDF when I started this. Yeah, here the answer is 1. Here the answer is 1. So if the question asks how many calls,
So that's the next question.
okay, that is the next question. Yeah, here the question has been how many times the procedure calculate called in order to compute 14 commas. So for this the answer is 9. So since we call 9 times, so the final answer which we got 1, that is the answer. If the question is asking how many times the procedure calculate call, so just count number of times I call the function, so that is 9. Okay.
Sir, why return value is 1 after
Why?
recursion?
Finally we got 1, right? This is the final call, the 9th call which we got,
The
which is
return
calculate 1 comma
return
1.
B.
Yeah, in this case the condition A equal to B has been satisfied. Here it will return B, right? Which
Yes.
is my 1 value. That's why the
Yes.
final value is also 1. If you keep on backtracking, this will also be 1, 1, 1, 1. So final value will also be 1.
Yes.
So the 6th question is asking for any two positive integers a comma b, what does this function actually calculate? This calculate a comma b, what does this actually calculate? Whether it's calculating LCF or HCF. You can directly eliminate the third and fourth option because it says it calculates LCM or HCF only if A is greater than B. This is not true, right? Even if it is A is greater than B or B is greater than A, it reverses it, right, in the function. For example, this 14 comma 17, we just reversed it and calculated the value. So this third and fourth option is not true, right? And the second option is the only option which is true because the 14 comma 17, if you take the LCM, so the LCM for this will be 14 into 17 since there is no common factor between 14 and 17, right? Because the 17 is a prime number. So for prime number, it will be only divisible by 1 only, right? So HCF is nothing but highest common factor. How many of you know what is mean by LCM and HCF?
Yes, sir.
Yes, sir,
I
we
hope
know, sir.
everyone knows because
Yes.
some of them comes from non-mathematical background. That's why I'm asking.
Sir, it is a
They
topic
might
from
have,
primary school, sir.
yeah, but it might have been forgotten. That's why. Okay. So here the highest common factor is 1, right? And if you take the example of the previous one, which is 12 comma 3, the highest common factor is 3 here. 3, 4, 1. After that, there is no common factor. So the highest common factor is 3. But if you take the LCM, this LCM will be 3 into 4, which is 12, which is not your answer. It returns only 3. So this function actually calculates the HCF of two numbers. So it calculates the highest common. Okay. Shall we go to next one?
Sir, how it is, how it returns to the SCF of the two numbers?
So you just take an example of previous two numbers, whatever we see. In case of 12 comma 3, it returned 3 as an answer, right?
Yes, sir.
And in 14 comma 17, it returned 1. So what is the common number that is divisible for both of the numbers? Only 3, right? If you take 12 comma 3, and only 3 is the common divisible number, right? After that, can you divide something? This 4 comma 1. Only you can divide it by 1, right? Other than that, you can't divide any number commonly.
Yes, sir. Understood.
Again, the same case happened with 14 comma 17 also. You can't divide this 14 comma 17 with any common number except. So that's why the highest common factor is 1 here. Here it is 3. Okay. Okay. Next question. It's simple question again. So what is the result of the following expression? Assume a and b are two positive integers. Calculate a comma b equal to calculate b comma a. So they are just asking whether I can take as an example here whether 14 comma 17 will be equal to calculate of 17 comma 14. It will be giving same value, right? Because my procedure automatically reverses it if it finds a greater digit.
Yes.
So this will be always true. Okay, next question. Okay, this is the final. Cool. Okay, any doubts so far here in practice assignment?
No, sir.
Everything clear, right?
Yes, sir.
I know some of you still might have some confusion in recursion, and for that, practice is the only way. Even when we started this by studying in the first year, it was felt like that only. I can't say it. Okay. Any doubts before closing the session? Yeah. Thank you, Ankit.
Thank you, sir.
Thank you.
Thank you, sir.
Yes, sir.
Okay, then we'll wind up the session. Thank you everyone for joining.
Thank
Sir,
you,
what
sir.
is tomorrow's class, sir?
Tomorrow we don't have any session, right, for CT?
Yes, sir.
Okay, it shows in the calendar, so I was confused.
Calendar, I don't know.
So
The
Google Meet,
calendar,
sir.
Google Meet.
TA
Sir,
session.
For CT, we
the
don't
TA,
conduct any.
the
Okay,
TA
TA session.
session is, yes.
Okay, I'm not aware of TA session schedule. Sorry.
Can anyone tell means if I want to revise something like 11th week, so which lecture I should prefer? Because on YouTube, many of lectures are not available of like these kind of session, TA session, if we find there.
Yeah,
So
TA session won't be available in YouTube. I
yeah,
don't know whether the TA sessions are recorded. If it is recorded, you might ask the TA to provide the link. The TA
yeah,
must
but in link,
link.
but in link 11th week means recorded session are not there. Means I think they have not took the session for 11th week.
Okay. So that means if they haven't taken, there won't be any session for this term. If
If I
tomorrow
want,
is the
if I
TA
want,
session for week 11, they will be recording.
yeah. If I want for previous means batch TA sessions, do you have any idea from where I can means get this?
Just check with the TAs if you are joining the TA session. It's posted in the discourse. TA will be giving the link in the discourse.
Okay. And one thing I also want to ask all of you that how I can means I once I mail to the ITM that I have got, I don't know what is my house, so they provided something means my accordingly to my location, they have provided some kind of links in which, but it is not clickable. So how I able to join this house?
House.
Yeah. Do you have any idea?
Have you got your house name?
Yeah, I got my house, and also there is list in which many kind of links are there from with the name of your house. So how can and
I'm
where?
not sure whether they are providing any links to join
No links.
any.
Some kind of as many kind of websites are means I how I can explain
It's
list in
not
which
official,
many.
I guess,
No, it is
because
official.
as far as I know, officially they reveal your house name based
Yeah,
on your location.
yeah.
After that, you will be automatically added to the Google Space. If you have a student mail ID, you can see that Google Space chat will be there for your house. That will
Can
be
you
automatically added.
Google Space? Can you
There is
provide it
no
link?
official WhatsApp group or
No,
any
WhatsApp
links,
group,
I
no.
guess.
It is not a WhatsApp group link. It is a kind of means link. I don't know what kind of it is because it is not clickable, so I'm not able to visit it.
Okay. For that, you need to mail support only, support or student affairs. I don't
Sir,
As
think a
what
link
is
will.
house?
Hmm?
What is house?
house is like
Sorry.
in which, for example, as you were in your school, there were many house like red, blue, green. So such kind of house also there in our this degree.
So basically, houses are kept for encourage student activities to among yourself.
Yeah, right.
So there are some various sessions and activities that is being conducted that is lead by the students only. But that's it. So we'll get to know once the term is being completed. Those who haven't got student ID, you may not know what is mean by houses. But once you got the student ID in your next term, so that will be shared with you also. Okay, guys. Thank you everyone for joining. I'm ending this meet.